can see your screen.
Perfect. Okay, cool. So thank you for joining in from, diverse places in the world, and also for spending time and having an interest in Zing. The talk today that I wanted to kind of run by is just how to maximize, the accuracy and performance that you can get out of Zing, because I believe that's probably the most important thing that all of us are after. And I would like to cover some of the key internals within Zing, and what kind of configuration and what kind of training actually impacts the accuracy and the performance that you get. Feel free to stop me at any stage because it's a small group, and would love to take your questions as we go along. So the goal, I think, while building Zing models, and also as the key developers behind Zing has been that we want to ensure that the matching happens in a performant way. Very this the problem of entity resolution by its very nature is a compute intensive problem, and the goal behind all the training and all the configuration that users do is to optimize two main things. One is to have really performance matching jobs, jobs that perform well within the time duration that you want your results. And second is that they are as accurate as possible with a balance on the precision and the recall. So there are two aspects of accuracy that Zing optimizes on. One is precision. And I mean by precision is that when Zing says that there are two records that match with each other, how accurate is that for the user? And that is an important step because you want to trust the results that you're getting. Second is of all the problem space that you have, is Zing able to give you all the pairs and all the matches that exist in that problem space? So if there were, 100 pairs, 100 kind of records that would have matched with each other, has Zing given you all of them? Has it given you 90% of that, 80% of that? That is called a statistic. Statistically, it's called recall. And Zing internally balances between precision and recall. I think somebody's logging in. Okay. So that's essentially the internal aim that the optimization that we do, and all this is seamlessly done. You would probably not even be thinking about this while you're configuring Zing, but these are core aspects that these Zing algorithms kind of train and tune on. Now, coming to time, time is obviously one of the most critical factors when we think about entity resolution, and the reason is there are absolutely no unique keys on which we can actually join these records together. So the space of computation, the space of comparison is really huge, and it is very difficult when you have, let's say, you have 10,000 records. You want to compare those 10,000 records against each other without any unique join key. The Because the comparisons are so huge, Zing has internally something called a blocking model, and its goal is to quickly bring the near similar records together. So it is, in a way, it is a broad based clustering, very custom to the problem that is at hand, and this is also learned while you are labeling your data sets. So when Zing is showing you the fine training data phase while you are doing the labeling, the blocking model is also being learned. And some of the aspects in the blocking that affect, and blocking is completely learned from the records that you mark as matches, not the records that you mark as non matches, but it is completely based on the records that you mark as matches. On the records that you mark as matches, on all the fields, we apply different kinds of hash functions. Some of them will be like when you're marking records, do the first two characters mostly match for a particular field? Let's say first name. If that's something that is a good way to bring those near similar records together, Zing would actually block them together. So let's say like you have uh, records across multiple cities, and in all likelihood you don't want to record to match records which are across different cities. So Zinc would learn that from the training, because you would always be marking records which belong to, let's say, San Francisco as matches, but a San Francisco and a Fremont would not be marked as a match. And that's how Zinc would actually learn that whenever the records the user is saying are a match, the state or the city is always a match, and probably it's a good key to block on. But it's not only equal, we actually do very fine grained hash functions, and it's actually a tree that we create out of it. It goes over all the fields that you define as part of the blocking, as part of the field definitions. All the fields that you mark as don't use are not used in the blocking, but all the other fields on which you plan to run any kind of matching are considered in the blocking. Now, the second aspect for Zing is similarity prediction, which is essentially that if you are two records which are in the same block, are they a match or are they not a match? And internally, we use a log reg classifier for that. The features are created based on the match types from the field definitions that you select. And together, these two important aspects of Zing help you balance between the accuracy and the performance, the precision and the recall. Now, really, what knobs does a user have here? A key aspect while building Zing was that, a user is like potentially doing a ton of other data transformations. They are putting in their data pipelines together. They're bothering about the business functions. And we don't want them to be bothered about algorithms or weights or thresholds. We want it to be as simple of an interface as possible. Say yes, no, can't say no, not sure, and based on that, let Zing learn. So that was, in a way, as a design principle, our approach has been that the user should not have to worry about tuning Zing, about tuning Zing for performance or for accuracy. It should come to the user out of the box. But still, obviously, Zing results are very, very dependent on how you use Zing. And the knobs available to the user are something that are very intuitive to you. They are not entity resolution domain specific that you need to worry about. You don't need to pick up a new skill or even machine learning skills or even Spark skills. What, however, you need to know deeply about, and that those are things that you probably already know. And those are the ones that, with a bit more awareness that the impacting would help you derive maximum mileage out of your Zing deployments. So things like your own data, which you already know, what field definitions you choose, how you configure the match types, and the number of labels that you actually make. Essentially, these are the main things that impact both performance and accuracy of Zing models. Now let's look at each of them one by one. So essentially, I think what we think that most users would know is that they already have an understanding of what their data looks like, which fields are well populated, which fields do not make sense, what kind of variations exist in your data. So some level of understanding is definitely needed, and I think most users eventually, when they start looking at Zing, they're already aware of the problems in their data. and they kind of know that some there are common words in particular fields. There's some level of data cleansing that they know that they can already do. The data is already denormalized. So to that extent, I think most people kind of um, are aware of what is their data like and what are the fields that are worth it for them to be a consideration to be put into Zing. Now, coming to choosing the field definitions, I think this is something that that just I just wanted to highlight. I think most people do it right, but the idea here is that even if you have like 15 columns, but your aim would be to choose the smallest number of distinctive and well populated fields for matching. I say well populated because if those fields do not have data, like if majority of them are like nulls, I mean there's absolutely no signal that Zing can derive out of them. A null is a null, and there's it could be treated as a match or a non-match based on how you configure, but then it's not really very helpful. However, if you have data which is mostly 70-ish% populated, and you think that adding that to your model really helps, those are fields that you should definitely look at. uh, another way to look at those fields is like, is this field distinctive enough? If all my data is like the state of California, it's not distinctive, it doesn't matter for Zing. You probably don't even care about putting it in the field definitions as a match type. You should probably don't use for those kind of fields. Now, sometimes because Zing is like an ML based or an AI based platform, people assume that it will be able to figure out that M is equivalent to male and 1 is equivalent to male. But that level of intelligence mostly is kind of that's more like on a data preparation side, and that's not something that we do, at least not as of now. So that kind of if you have some data like that, it probably makes sense to standardize that. Also, for fields, as of now, Zing is still non-semantic to some extent. A doctor and a physician, and a lawyer and an attorney, uh, for a human they may mean the same thing. To Zing, because it's still doing string edit distance, etc., they don't mean the same thing yet. However, if you have semantic needs, you could actually put in embeddings for those corresponding fields and use array type, which is a type, and Zing would be able to actually match them. Now, when we look at choosing the field definitions, I think the biggest thing here is the match types. Now, what essentially does match type internally translate to? Internally, match types translate into the features, the machine learning features for the classifier. And one match type will translate into one or many features depending on what kind of a match type it is. So if you look at fuzzy is something that we say that you have variations in the field, possibly typos or abbreviations, and you still want to go ahead and match those records. Please remember that matching happens not only column wise but also the entire row in entirety is considered for a match. So even if something is not matching exactly or it is matching exactly, that alone by definition will not really be the only test. The entire record in entirety would be looked at, and only then it will be decided whether it is a match or non-match by Zing. So if you choose a fuzzy match type, internally it will translate to 2 to 3 features. It can be applied to string integers, double states, and it will be tolerant to the variations in those fields. And as you mark your records, as you label your records, it will learn to what extent a variation you are happy with, and that is where it will learn the what is the right value for the feature weight or for the column weight that it needs to apply. So sometimes, people are asking us whether there is some weights that they can change or some field settings that they can change. You don't need to really bother about that. As you are labeling with the match types that you are choosing, Zing would automatically pick up which fields are important to you, what level of variations are important to you, and that is pretty much what you need to be bothered about. So we have all these match types. Don't use is something that we really advocate people to use for IDs and other fields that you want to appear in your output, but not really in your input. They don't ever contribute to any kind of matching. We have some specialized match types like email and pin code. The null or blank is very interesting because if you have, let's say, a data set which is like a column which is like around 70% populated, you still want to put it into Zing. By default, Zing is going to treat all your nulls. If two records have null values, that column would be treated as a match. But if you want to indicate separately that this was a null, Zing would record that, and it will start becoming intelligent about the kind of null matching that you're doing. And you can get different results. So sometimes you want to ignore results where one of the attributes is null. So you can get those kind of results using a null or blank. It is powerful, but it needs more training compared to not using that feature. I think the idea here is that obviously the more match types that you have per field, and just to add to that, you can actually add more than one match type for a column. So you can have, fuzzy, comma, um, uh, let's say, I think we have some of the other ones, like fuzzy, comma, numeric, where you say that, I am worried about variations in the field, but I also want Zing to pay specific attention to the numbers that appear in this column. And I want you to pick out those numbers and compare them also and make sure that how I'm labeling is how the matching is reflected. So you could actually, have multiple columns, multiple match types for a column, and accordingly, multiple features will get created. So that's something that you can definitely try if you want, specific match types to happen. These match types that I have in front of me right now, the numeric with units, only alphabets exact, only alphabets fuzzy, force Zing to create custom features, specifically extracting data out of that column. And that is an indicator that, as you label, it will learn that kind of a pattern and make sure that it matches according to that. Now, a thing to keep in mind is that, the more mass types we have, the more labeling we will need because we are creating more features and Zing needs to learn that. So if, because, from if you we've labeled two records as matches, and it's actually deriving multiple features out of those columns, it needs more variation in the training, so you need to probably add more labeling compared to what you would do otherwise. Similarly, more match types will impact the performance, not drastically, but they will definitely have a hit. Like if you're, for all your columns, if you have 2 to 3 match types, that is definitely going to have a hit on your performance. So choose wisely, because essentially it means that Zing is actually processing more. Now, sometimes I think a very simple rule for labeling is that when we are when we look at the data, like intrinsically, sometimes we know that this person has moved. So I know this customer, this person has moved to a different city or a different address, and yes, they are matches to me, and Zing would probably figure out. But do that as treat the first Timothy Chen as a match only when you're sure that the second Alexandra Hutton record, which also have different addresses, can also be treated as matches. So the labeling has to be consistent. If you're okay with addresses being different for the same person name, it's okay to label them, as matches. But if it's just human knowledge, if that signal doesn't exist in the data, there is no way for any application to learn, and your results will not be consistent. So that's just something that you need to keep in mind. Now, how do labels kind of help us? I mentioned already that the blocking is very dependent on how many records you label. And you would see that there is a warning in the logs which says that this is the number of comparisons that Zing is making. As you label more, this number of comparisons will reduce. So anytime you feel that your performance is not good, a very likely scenario is that there isn't enough training data and the blocking model has not been accurate. And you can actually look at this line in the logs and see if the number of comparisons is really huge. You probably need to reduce it. You can add more training there. The second aspect to labeling is that field combinations are covered. As you label Zing, you will see that it starts asking you, showing you pairs which are, like, let's say the first name is different, or the first name is same but the last names are different and the states are maybe nearly same, stuff like that. So it will show you different field combinations, and just when you're labeling, just try to make sure that in totality those kind of combinations are covered. It has actually been able to look at some variations in state, some variations in your other fields, to create the right model. Our general rule of thumb is that you get to 40 to 50 matching records, and probably you would have covered mostly all the field combinations. But in case you feel that that's not happened, you can actually force feed stuff into Zing through training samples, or you can uh, just go into labeling a bit more of data, making sure that some other aspects of your data are also covered. Now, I think some exciting things that we are working on, which is just to improve the usability. We've actually been working on a couple of things based on some of the deployments that we have done over the past few months. Some of the user feedback that we have got. One of the aspects is that if there is an unbalanced training samples manually added by a user, and the match jobs start failing and the user doesn't really know why Zing is not performing. It's doing a lot of disk writes. Jobs are failing. So we are actually going to give you knobs to verify that your blocking model is actually well trained, and there is going to be a way in which you can actually figure out that your blocking is your data is well spread into the blocking, and your blocks are well, some blocks are not really huge and some blocks are very small. So that is something that we are planning to expose to help with debugging some of the Zing jobs. Another aspect that we are actually working on, and these are honestly very experimental at this stage as we speak, is that as I mentioned, that the job of the fine tuning data and the label phase is to get to so we learn a lot from the matching records, and we also learn from the non-matches, but we learn more from the matches, and we're trying to optimize the flow for the fine tuning data and label, that we can show you more matching records than the non-matching records. Because I think right now what happens is that we start with trying to show you 10 matches and 10 non-matches, and mostly those in the initial rounds you end up with just the non-matches, and it takes a lot more cycles. So that's one more phase that we're trying to see as an experiment. If that works, it would be nice for you to be able to iterate quickly on a model and uh, get to a functional Zing deployment faster. So this is again an experiment that we are working on to alter the samples that we're showing to you, lean in more towards probable matches, get to positively actual matching results faster, so that you can label more quickly than you can currently, and somehow get to better, a faster deployment in that sense. Another aspect that we are also working on is, just improving the blocking tree, the way we look at the fields, make sure that we can cover more of the columns within one single run, so that your models can converge faster and it is a lesser time for fine tuning data and label. All of these are, as we speak, these are just experiments we are actually working on, and we'll keep you updated on how they work. I think the biggest challenge for us is that we don't own any data or any data sets. We have some customer data sets that some of the techniques we've applied on, but they are it's likely that we got good results on that. So it's very difficult for us to actually just say generically that they will work for most of the data sets. And that's why I say that they're still experiments. And I would love it if, we could try them on some of the community users if they're interested, helping us with that. Um, it would be much faster and easier to roll out. And I think just to add to that, in the like a coming release, we are also adding ton of blocking tree optimizations, so that so this is something we've already done in the enterprise project, but we are bringing this to open source, so that when you're running fine tuning data, it runs much faster and you can converge to models much easier. So this is pretty much what I wanted to kind of talk about today. I would love to hear your questions.
Hi, Sonny. Thanks very much for you just shown. Was really interesting. It's a question I actually raised already on chat with you. I was thinking about quality metrics, like the precision versus recall that you earlier mentioned. So we had some questions coming from a team. That's that if there was a way to kind of look at the internal quality metrics that have been used by the model to try and evaluate the results faster and better for us. Because currently, as you mentioned, this is not a feature that will be available for the community version, but it would just be available for the enterprise, which is fine. At the same time, we actually kind of, as far as I can tell, for what I've seen by the earlier tests, it seems like the community version, the open source version, is actually fine for our needs. So, but at the same time, the team was actually worried about the fact that there is no way for us to look at the quality metrics and trying to quickly evaluate our results rather than simply going and check the output, because let's say we got millions of contacts and we need to dedupe, then it would be inconvenient for us to each and every time we train the model to go and check some samples of the data. So we actually needed a faster and quicker way to actually see, oh, this is actually what we want, by looking at some precision versus recall, some quality metrics, for example, the column importance scores, which at the moment we don't have access to. So I guess the question here is, do you plan for releasing this feature even further to the community version, or you just is a kind of a feature that will only be available with the enterprise version?
Okay, so thanks for the question here.
Yeah.
Yeah, so precision and accurate, recall something obviously we care about a lot. But what we think is, and that's completely what we've seen on almost all the deployments is just having the model accuracy, right? Just reporting on what the model is learning from the training data. See, you're giving what, 40 samples, 50 samples to the model. uh, that stat is not helpful. It doesn't translate
Hmm.
production, your match output stats. The reason is that your data is obviously changing. You're bringing in fresh set of data. You're linking what you've trained on the model is only a very small proxy to what actually it's happening on the output. So that's, and like if we knew on the output what we are missing, if we're not accurate, we would have actually solved it. So it is, in some ways it's a tricky problem. That how do we do that? On the enterprise side of the product, we what we've done is we've actually added all the hooks, because it has a lot more stuff that we've already built in terms of the framework. So there we actually are able to kind of expose, what are the features it is generating,
Hmm.
what are how are they playing up in combination. If three records matched with each other but only two of them genuinely matched and one was like a transitive match, it only matched with one of the records, a user is able to figure that out. So those are things that, on the obviously on the enterprise side we've been able to add, just because of how the code base is structured.
Hmm.
I'll definitely take your suggestion and think about ways in which, we can do something for the open source. I think for now, maybe if you have like a golden data set, right, you can compare your results against that for the model and
Hmm.
see if that's something that you want to benchmark against all the time. So if you're changing a model, you can see that, in my previous data set, it gave me, let's say, 80% accuracy. But
Hmm.
when I changed my model, I changed my match type, it is now going up to 85%. So this is a better model to choose. So that's one thing that I see people doing on the open source community side. And I think
Okay.
that's first step, that, you have some kind of a golden data set or a truth set or something, and that you can actually benchmark against every time you put in a new model.
Okay. Yeah. Thanks. I mean,
Sure.
that's fair enough. And then I got another questions about the link phase. We've been testing the linking phase for a while because we need to have an incremental way of find dupes against an already deduped kind of historical data set against a delta data set. So as far as I understand, the incremental delta also needs to be duplicate free, right? But that step was actually needed with the fine incremental matrix, which is the other model that we've been using on. So it seems like that we first need to find the matches against the delta. We need to then remove the dupes from it, and then we run the link phase. Is that correct?
The link phase, as I remember, would actually do a best match of the second data set against records in the first data set. So if there are three matches it finds in the first data set,
Hmm.
it will link against all three. I don't think we have a restriction on uh, they being duplicate free or something.
Okay, that's good to know because on the documentation, I've seen that actually you mentioned that the data set needed to be duplicate free, but maybe I'm wrong. But I
So
think
the
as far as
best,
I,
yeah. So the best use of link is obviously that, those two records. The idea behind link is that those two data sets are duplicate free, and you want
yeah,
to match one against the other. So that's always been the idea. In terms of implementation, I may be wrong here because it's been a while since we looked at link. Mostly we work on the run incremental phase in the enterprise product, and that works
okay,
differently. So if you see something else different from the documentation, let us know. We'll check and get
okay.
back to you on it. Yeah.
Yeah, okay. Okay, so I'll run some tests. I actually ran some tests already with having some dupes in both data set. It was producing some results, but well, I thought maybe it would be best if we just remove the dupes up front and then we run the link phase. But if you're saying there's actually technically no difference by doing it or not doing it, then I would probably avoid running an intermediate step like removing the dupes first because that will add complexity and it would increase costs as well. That's fine. And I was also expecting actually, to be fair, to have as a result the same number of records coming from the historical data set plus the records from the delta, but I realized that actually not the case because we might have multiple kind of records, so duplicated coming from both data sets. So the results won't necessarily be like number of historical records plus number of incremental records for some reason, but that's maybe something else.
So link, yes, link would only show you the matches. It was not meant as a.
Yeah,
It's supposed to link, find the links, right? So links
yeah.
are what you has matched.
In that case, then I will need to then post-process the results, because
Yes.
our requirements would be to have the original data set plus the delta, well, kind of being as an output to the model itself. So if links doesn't do that, then obviously that needs to be post-processed. But that's good to know at least. Yeah. Thank you.
Sure. Any other questions? Aaron?
Hear me?
Yeah, we can
Hello,
hear you. How are you?
I'm doing well, thank you. Appreciate this.
Do you have any questions, Ron? How are things going with
I do
you?
not. I do not. I've been listening and kind of looking at some of the things that have been updated lately. But I do not have any questions. Thanks.
So any feedback, I think, any, anything that you want to share, especially I think for the people here today, if there are data sets that you think we could use for some of the features that we're building, if there's any feedback on the fine tuning data and the labeling phase, please do let us know. If you've not had, if you've had trouble with accuracy or performance for Zing, if your jobs have failed, those are things that we're very actively working on right now, and we would really love it if we can get some of your feedback there.
Sounds good.
Uh, Anybody else? Okay, cool. So I think this is pretty much it from my side, and you know how to find us on our Slack and GitHub. If you've enjoyed you know, if you just like the project, if you think it's valuable to you in some ways, if you want to do a case study, just help the community with some use cases or some documentation, it'd be a great help to us. And in any case, thank you so much for joining. And I hope you have a great run with Zing, and just let us know how things are.
Thanks very much.
Yeah, cool.
Thank
Thank
you.
you.
Thank
Bye.
you so much. Yeah, bye bye,
Bye. Bye.
everyone.
Bye.
Thanks.